Okay, so up to this point, you guys should know the difference between an arithmetic sequence and a geometric sequence. Someone quickly tell me what's the difference. What's the difference between arithmetic? Okay, so I'm going to say it just a little bit louder. Arithmetic means you're adding or subtracting the same number throughout the entire sequence to get to the next number in the sequence. Geometric is kind of like that, except you don't add and subtract anymore, you multiply. Now, I didn't say divide because when we divide, we really just multiply by a fraction, right? So if I needed to, like, I don't know, divide by 2 every time, I don't put divide by 2 into my formula, I put times 1/2, because that's the same as divide by 2. So we also learned that there are some formulas involved in both the geometric and arithmetic sequences that will allow you to jump straight to the term that you need. For example, if I ask you to go to the 20th term, you just substitute in n equals 20 into your formula. Type it on the calculator, it'll spit out the number that's in the 20th spot in the list. We're going to do something a little bit different, and I don't know what's the point of this. It's called a recursive rule. Now, when we saw the formulas yesterday and the day before to find the nth term, that to me is like the shortcut. It gets us straight where we need to go. A recursive rule is a little bit different because it doesn't allow you to take a shortcut. So for example, if I asked you to find the 20th number in a list, you would have to find 1 through 19 first. There's no way around it using these types of formulas. I will tell you though, they're never going to be that mean to you. So they're not going to make you go 20 numbers in. At most, probably 5. And I'm going to be honest with you, I'll probably just use the explicit formula because the explicit formula is the shortcut. I'll show you one time though, like how much work is involved, and then I could care less how you get to it. The only reason I need to show you how to actually do it is for, you know how always on the test there's a question that says, Jessica did the question wrong, go find her mistake. That's why I need to show you how to do this stuff by hand, just in case that's the question where someone messed up and you have to understand how to read it. So I want to, I think a big part of understanding how to do sequences and series when it comes to the formulas is understanding the notation. There is a part that has to be in your formula because what we're going to do is we're actually going to create our own. Now, when we say, let's say, when we say this, that represents like the nth term, right? That's what it means, the nth term. We use a general n because I don't know what number I'm going to be needing to find. So if I say the 10th term, then it's a sub 10. If I say the 25th term, it's a sub 25. This right here, I'm just defining the terms again because this is super important. When we do a recursive formula, we have to use this as part of our formula to find the next number. So think about this. If this is the term that we're looking for, what does n minus 1 mean? So let's put some concrete examples in. Let's pick a number. So if I wanted to find the 10th term, this would say a sub 10, right? So what would it say right here when I put the 10?
After you subtract.
Yeah.
No.
Okay, so a sub 10 means the 10th number. So if I put the 10 in here, it's always going to take 1 away. So it's going to tell me the 9th number. So this right here, this is the notation that means the previous term. When we generate our formula, we have to use that. That's going to be the way that we figure out how to get to the next number. We have to know the number before. Now, the thing that's unique about this is there's 2 parts to your formula. There's the actual formula that you use to compute some stuff, but then you also have to give everyone your starting point. The formula itself will not tell you the starting point. So we always have to define the first number in the list. So when you write your own formulas, you're going to automatically get it wrong if you don't put this part. Because, the formula will tell you the next number, but you can't get to the next number without the previous one. So if you don't know the first one, you can't get to the second one. So you always have to define what the first number in the list is. Now I'm looking at this formula, and I just realized this is a horrible example. Because,
that example is how you write your answer?
well, no, I'm going to show you how it works. So you can see, like, how to find the next number. But I just realized the title of my notes say recursive rule, and then in parentheses it says arithmetic. I'm looking at this right now. I just realized it's not arithmetic. And you'll see why in a second. So do we know a sub 1? Absolutely. We have to, because we can't find the next number without it. So they told me in the formula up here that the answer is 2. Now think about this. Like, if I was going to plug in the 1 in the formula, I would not be able to do it because right here I get 1 minus 1. I don't have an a sub 0. There's no such thing because the first number is a sub 1. A sub 0 means the 0 number in the list. What the heck does that mean? Doesn't make any sense. So our formulas will always start with 1. So that's the first part. So now, starting here is where we actually have to use the other half of the formula. So I'm going to just like substitute. So check this out. This formula says 3 times that. So I'm going to do 3 times, oh, I hate this part of the board. Hang on, let me raise it. 3 times a. So remember, when this is 2, that means n is equal to 2. So the formula says 2 minus 1. Now, can we simplify that? 3 times a sub 1. Don't we know the answer to a sub 1? What is it? Bless you. What's the answer to a sub 1? It's 2. So the answer to this first part is 6. So the second number in the list is 6. Now, we would not have been able to arrive at that if we didn't know what A1 was. So that's why it has to be defined in your formula every single time you write your own formula. So you're going to notice a pattern, hopefully. So if we move on to the third term, we're going to do 3 times A, 3 minus 1. So that's going to simplify to 3 times a sub 2. Do we know the answer to a sub 2? Yeah, it's 6. It's the answer we got from the last problem. And that's the whole idea of what a recursive formula means. In order to get a sub 3, I need to know what a sub 2 is, because I'm going to use it as part of my work to get to the next number. So a sub 2 is 6. So that means a sub 3 is 18. So if I go all the way out to the fourth number, following the same formula, this is 3 times a, and it's always n minus 1 because we have to use the last answer. So this would be 4 minus 1. Since I'm on 4, I plug in 4. That part right there gives me 3. So I know the answer to a sub 3 because I just did it. It's in the previous step. So this one right here, this means 3 times 18. Was that 54? Oh. So a sub 4 equals 54. So if I asked you to find the 5th number in the list, you would not be able to get to the 5th number without finding 2, 3, and 4 first, because the formula requires that you know the previous number. And that's the whole thing about what a recursive formula means. A recursive formula means to get to the next number, you have to know what the previous number was, because you use that as a part of your calculation to get to the number you need. Did that make sense? Okay. So here's what we're going to need to do. We're going to need to write our own rule. Writing our own rule is not very difficult, especially when you know that it's an arithmetic sequence. So again, an arithmetic sequence means that you add to get to the next one, or you subtract to get to the next one, and it has to be the same number every single time. in order to do this, you're going to need to define the first term, always, because you have to have a starting point. The second thing is you have to write a formula that includes n minus 1, because that's the whole thing about a recursive formula is you have to use the previous term. So here's what we're going to do. It says, write an explicit formula and the recursive rule based on the given information. So first of all, I'm going to ask you guys this question. Look at number 1. Is that an arithmetic sequence or is it a geometric sequence? What do you guys think? Think it's geometric? Okay, that is false. Let me tell you how I know. When we use an arithmetic sequence, it has something called the common difference, which is the letter D. They gave us the letter D. So that's how I know it's an arithmetic sequence. In a geometric sequence, the one we did yesterday, they don't use the letter D, they use the letter R for the common ratio. So you can tell what type of sequence you're looking at based on the letter that they gave you. If it's the letter D, it's an arithmetic. If it's the letter R, it's the geometric. So this is definitely arithmetic. Now there's two parts to this. They want us to first write the explicit formula, which we've done before. The explicit formula is the one where you use the nth term formula and you plug in those two things. And it'll give you the explicit formula once you simplify it. Now I know that the words that I'm saying right now are a bunch of mumbo jumbo and you're not even paying attention because I can see a bunch of phones and stuff like that. But you're really going to need to pay attention to this. I'm not just speaking because I sound good. You know what I'm saying? I'm trying to be very thorough in my explanation because, guys, once you get past all the fancy words, it's not that hard. So you need to know what arithmetic means, you need to know what geometric means, and you need to know what explicit means. If you have an explicit formula, it comes from the ones that I put in the big fat boxes in your notes. So turn back to 11.1 and we'll find the big fat box. There should be a big fat box somewhere. I think it says this. So I'm going to list the explicit formula. The explicit formula says, take the nth term formula and plug in the first term and the D and simplify it. So I think it went something like this. A sub n plus D, and then n minus 1, right? That's the one that's in the big fat box?
No, it's a 1.
Oh, sorry. I was supposed to say equals. A sub n equals A sub 1. That's the entire formula. So to write an explicit formula, all you have to do is plug in these two numbers and simplify it. So I know the answer for the answer for A1 is 4. So 4 plus the difference is 5, and then I have n minus 1. So if I simplify this, this ends up saying 4 plus 5n, oh, I keep putting an x. 5n minus 5. And then I combine like terms. So I have negative 1 plus 5n equals a sub n. That's my explicit formula. Now I'm going to teach you how to write the recursive rule. The recursive rule is pretty easy when it comes to an arithmetic sequence. Watch how simple this is. What is this called? Oh, recursive. So the recursive rule looks like this. A sub n equals. Now when we do this formula, we have to use a sub n minus 1. There's no way around it. So that's the first thing I'm going to throw in. And the last thing you do is you just throw the common difference at the end. The common difference is just 5. So that means we're going to put in a number and add 5 to it. And then once we get that answer, we're going to put in a number and add 5 to it. There's one last part that we need to make sure we write down. Where are we going to start from? We're going to start from 1. We're going to start from 2. We don't get to make it up, you guys. Do you know how to find the first term in a list? Use your explicit rule. Just plug in 1. 4. 5 times 1 is 5, and then you just take away 1 from it. So there's a reason why we have the explicit rule. The explicit rule will tell you the first term every single time if you just plug in 1. So that's our recursive rule. I want you to try it for the second one. Come up with your explicit rule, and then after that, write your recursive rule. Okay, so again, to find your explicit rule, the explicit rule is the nth term formula, but you plug in the A1 and the D. So the formula says AN equals A sub 1 plus D times N minus 1. So we just put in the two numbers they gave us, -7 and -1. I don't care, I'll put the plus back, even though you don't need it there, N minus 1. Then the second step is distribute. -1N plus 1, -7, and then combine. Now guys, I saw some of you put the N in the front, and that's fine. I didn't on this example, on the first one, because I'm combining these two, so I threw them first, but I don't care how you put it. As long as you have both parts, it's fine. So there's your explicit rule. And then as I was walking around helping people, I realized I kind of misspoke. You don't have to use the recursive rule to find the first term. I already gave it to you. It's up in the top. So let me try to summarize one more time how to write a recursive rule. No matter what, you're always going to start off with this. I'm going to make it in bold. Always start off with this. AN equals AN minus 1. That's what makes it recursive. You have to use N minus 1. The last part to this is, if you know it's arithmetic, all you have to do is put the common difference at the end. The common difference here is -1, so I just put -1. Then you also always, I'm going to tell you this on the test, if you forget to do this, it's going to be marked wrong. You always have to define the first term. And earlier I said, you just plug in 1 to the explicit. No, look at it, it's right here. I just realized that. So if A1 equals -7. Now if you had the actual list, if you were given an actual list, you can come up with the same formula, because all you have to know is the A1 and the D. And you can just plug it all in. Okay, here we go. Word problem. It says the student deposits the same amount of money into her account every week. At the end of the second week, she has $30 in her account. At the end of her third week, she has $45 in her account. So how much is she putting in? Putting in 15 every time. It says write the explicit and the recursive rule for this situation. Okay, here we go. I'm going to divide this into two parts. We'll do the explicit on this side. In order to write an explicit rule, we have to know the common difference, and we also have to know the first term in the list. I'm going to write that over here. A sub 1 equals, and then the common difference. So what did you say the common difference was? 15. So we're adding 15 to the account every week. What's the first term? Yeah, it's not 30, because 30 is the end of the second week. So we have to kind of work backwards. If we know she's adding 15 every week, we work backwards and we find out that the first week she had $15. So for the explicit rule, A sub n equals A sub 1 plus the difference, n minus 1. Plug in the two values. 15 plus 15 times n minus 1. So we distribute that. It gives me 15n minus 15. Minus 15 cancels. It's just 15n. A sub n. Now, in an explicit rule, you don't have to define the first term because you can always find it just by plugging in n equals 1. So there's our answer to that one. Okay. Now for the recursive rule. Guys, the recursive rule, especially when you know it's arithmetic, always start with this. An equals an minus 1. Minus 1. To write the recursive rule, all you do is throw the common difference at the end. What's the common difference? 15. And then also define what the first term was. If a sub 1 is 15. Okay, the second question says, how much will she have in her bank account at the end of the 9th week? How do we figure that out? Plug in what? I got two formulas up here though. Yeah, me personally, I would probably use the first one. Because, I mean, if you did the recursive rule and you need to get to the 9th week, you know how many problems you have to do there? You would have to do 8 plus the A1. So that's like 9, I guess. I think it's more practical. And if it wasn't a late start, we probably would have done the long one so you can appreciate the shortcut, which is what the explicit formula is. But I'm just going to use the explicit formula. A sub 9 equals 15 times 9. The only time you have to use the recursive is if they tell you to. If it said use your recursive rule to find how much she's going to have after the 9th week, sorry, you're just going to have to do all the work. But they didn't give me any guides, so I'm using the explicit one. What's 15 times 9? So $135. And I think that was it. So the recursive rule, not hard to write. You write a sub n on one side, a sub n minus 1 on the other side, put the common difference at the very end, and then tell me what the first term was. Those are all the parts of the recursive rule.